Home and office environments present difficult challenges for robots. We believe that remote assistance from a human may help speed up deployment of robot technologies into everyday use. In our system for remote human-in-the-loop manipulation, a user positions a virtual robot gripper in a desired six-dimensional grasp pose. The robot then carries out the grasp execution autonomously, avoiding collisions while moving to the goal. We have implemented a collision constraint algorithm that prevents the user from selecting a grasp pose that is in collision with the environment. Information about unfamiliar remote environments is usually limited to noisy and incomplete sensor data, often in the form of 3D points. Our algorithm can render six-dimensional interaction of a rigid object model, such as a robot gripper, with unordered point data. The algorithm is constraint-based, which means that interference-free poses can be enforced, and object pop-through problems are avoided. Here, the actual device position is shown by the red point shell, and the proxy location is the gray textured gripper. We compared user performance in a grasping task using two input modes, one using only a computer mouse, and one using a 6 degree of freedom haptic device for input with 3 degree of freedom force feedback. On the left, the human operator sees the view from the robot camera. On the right is a virtual rendering of the robot and 3D points representing the environment. The six-dimensional proxy constraint algorithm was active in both interfaces. Using the mouse interface, the operator drags on a set of controls to position the virtual gripper in a grasp pose. Since the proxy is not allowed to be put into a colliding pose, the algorithm prevents many unwanted collisions with obstacles. Using the haptic interface, the operator can control the position and orientation of the virtual gripper model while receiving force feedback from contact with objects in the environment. Haptic feedback conveys contact information in an easily interpretable form and also provides useful depth cues that are not obvious from a single viewpoint. These interfaces enable users to teleoperate a robot for grasping a wide range of objects, even in highly cluttered environments.